Okay, I'm back, and now let's talk about exactly what is light in the first place. Well, we said that light was a electromagnetic wave. So that means it's caused by electricity. Light is caused by electricity. And light in particular, light is caused when an electric charge, like a proton or an electron, accelerates. So you should know what the word acceleration means. So when something is moving at a constant speed and then it goes faster, it's accelerating. So when an electric charge, either a proton or a neutron, accelerates, that's what produces light. And so if you want to see an animation of it, you can go to this thing here at compadre.org, and you can click on it and you can make the electric charge go up and down. You'll notice that if it goes at a constant speed, it will not produce any light. You won't see any wavy action if the electric charge is moving at a constant speed. But you can change it so that the charged particle is going up and down. Now think about that. It starts at 0 speed when it's down here, and then to get up here, its speed had to change. So its speed is constantly changing as it's going up and down. What's another name for that? Acceleration. And so this time you're going to notice that there's waves that are going to go away from it. So that electrical charge is creating light waves. Now, what does light actually look like? So light is an oscillating electric and magnetic field. And so you definitely are familiar with electricity, but electricity can also cause magnetism. So magnetism and electricity go together, and that's why we call it electromagnetism. And so in this picture here, you've got, this is a picture of an electromagnetic wave. Now, I think you should know what a magnetic field looks like. So if you've ever taken like a bar magnet and then you sprinkle iron filings on it, have you ever seen that it makes a picture that looks kind of like this? Okay, this is the electric field of a bar magnet, or the magnetic field of a bar magnet. And it turns out that an electric charge makes an electric field that surrounds it. And so in this picture here, you see that light, it's a wave. So did you notice that it's going up and down? But it has two parts to it. The thing that's actually going up and down in a light wave is both the electric field, and perpendicular to it is the magnetic field. And the electric field doesn't always have to be the one that's going up and down. It could be the one that's going sideways, and then it'll be the magnetic field is the one that goes up and down. So that's what light actually looks like. And then another thing that we found out about light is it's both a wave and a particle. So prior to the 1900s, people thought that this, since it was made of atoms, would be a particle, and then light would be a wave, because light has a wavelength. Well, it was Albert Einstein in the early 1900s, he showed that light was also a particle. Light behaves like a wave, and light behaves like a particle. And we call a particle of light a photon, as in photon torpedoes from Star Trek. I couldn't help myself. So light is both a wave and a particle. So what do you think this thing is? Yeah, it's both a particle and a wave. So if I was to take this thing and throw it, you would say, well, every atom of this thing is moving in the same direction, so it must be a particle. Well, it is behaving like a particle, but at the same time, it's doing this. It's going up and down. It's just you can't see it. So its wave-like characteristics are so small that you don't notice them. But particles, or matter, is both a particle and a wave, and light is both a particle and a wave. Now, we're not going to get into too much about the wavy-like nature of matter, but it is important to know that light is both a particle and a wave. All right, in our next segment, we're going to talk about how the brightness of an object changes depending on how far away you get from it. See you then.